Hello, thank you for joining us online today for our presentation by the Canadian Society for Hydrological Sciences, CSHS. My name is Meg Olson, and I'm the Manager of Operations and Communications for the Canadian Water Resources Association. We are recording this webinar, and the presentation slides and a recording will be posted on cwberry.org and I believe the new CSHS website afterwards. Our presenters today, Kevin and Rob, will be taking questions both via the question window, where you can type in any questions you have while Kevin is speaking. And later on, they might switch to hand raising for audio questions, but they will tell you more about that as they present. So I'm going to introduce Kevin and Rob. You can see Rob right now in the in his webcam. Kevin, you can't see. But he is a research scientist at the Center for Hydrology at the University of Saskatchewan, primarily working on the problems of prairie hydrology. Kevin did his PhD with D.M. Gray, the father of Canadian hydrology, and worked as a flood forecaster in Alberta for about 10 years before returning to the University of Saskatchewan. He is a member at large with CSHS, and he is a member of the CSHS Hydrology Group. Rob Schlumsky is a PhD student at the University of Waterloo, who's working with Dr. James Craig and Dr. Brian Tolson on research focusing on topics including hydrologic modeling and decision-making. Robert is also a licensed water resources engineer and practices part-time at Ecosystem Recovery Incorporated. He's active in the CWRA and CSHS communities as a committee member of the CSHS Hydrology Group and sits on the board of directors for the CWRA Ontario branch. Thank you both for being with us today and presenting. And Kevin, you can take it away now.
Thank you very much. Rob?
Yeah, I think just before we get started, I just want to take 1 minute to acknowledge the protests that are occurring in the US and other major cities right now. And all I'll say about that is I would just encourage everyone to take some time to educate yourself and learn about why the protests are happening and maybe seek out some perspectives and life experiences that may not be your own. And for anyone that's going out in person, to remember that the pandemic is still here and do your best to wear a mask and keep your distance and stay as safe as you can. So. Yeah, thank you. Back to you, Kevin.
Okay. So, the title of our presentation today is Using Git and GitHub with R. And this is following on from a previous webinar, which we gave, a couple of previous webinars we gave on using R, which is becoming very popular for hydrologists. Before I get into this, I'd like to just give a plug to CSHS, the Canadian Society for Hydrological Sciences, which promotes the science of hydrology and its sound application in effective water management. It's part of CWRA. We put on courses. There's the Kananaskis course in hydrological processes. There's the Waterloo course in modeling, and the Sacre Coeur course, I believe, is in stream gauging. We also, CSHS also distributes or makes possible to distribute tools and modeling through the GrayJ website, and also the Hydrology R package, which I'll talk about a little bit more. It produces webinars such as this one, conferences, including at the CWRA annual conference most years, and also hands out awards and scholarships to students. So I encourage everybody who's a Canadian hydrologist to become part of CSHS. The CSHS hydrology package is going to be talked about a bit today, and it is an R package of functions for Canadian hydrologists. It's available on GitHub, as you see. Clicking on that link in this presentation will take you there. It's undergoing a lot of development, and we're hoping to deploy it to the CRAN repository sometime this fall. The issue is that we've got lots of people who are interested in helping with this package, but they are having issues with Git and GitHub. And so that's really the impetus for today's presentation, is to help you understand how Git and GitHub works and allow you to contribute to projects such as this one. So we'll hope that you'll be able to join us in making this package available for our Canadian hydrologists. So the purpose of this webinar is to get you comfortable in using Git and GitHub for your R projects, and to enable you to collaborate on projects such as the CSHS hydrology package. It's not going to make you an expert in version control software. Rob and I have been working with Git and GitHub for quite a while, and I don't think either of us would regard ourselves as experts. There's always more to learn. But at least we'll give you, today you'll be able to see the basics, and you'll be able to hopefully get productive with it very quickly. So the webinar is going to have three components. I'm going to be giving some slides, which are an introduction to Git and GitHub. Afterwards, Rob is going to be giving a demonstration showing you how you actually work with Git and GitHub. And then finally, we'll have space for questions and a wrap up. All the files that you're going to see in the presentation and also the demonstration are available online through this GitHub repository. So everything, you'll be able to download all the files that we're working with today. So,
sorry, Kevin, maybe just before we get into that, just a quick note that we do have over 100 attendees here. So having people jump in with audio questions, whenever might be a little bit tricky, but we are taking questions in either the chat box. And if you do want to ask an audio question, we'll probably save that for the demonstration portion because that's meant to be more interactive. But nonetheless, if you do have an audio question you wish to ask yourself, you can raise your hand in the you should see somewhere on your screen an option to raise hand, and we'll get around to questions. And if you're more comfortable or prefer to type it into the chat box, and particularly for the presentation, you can enter a question in the chat box and we'll make sure we get to those. And again, it is meant to be interactive, so please ask lots of questions and stop us if something isn't clear, and it'll enhance the presentation, I think, for everyone.
Thanks, Rob. So this is what I'm going to cover in the first part, and talk about what version control is, what Git and GitHub are, how to set them up, how to use Git in R, and how to work with GitHub. So these are the topics. So the first question is about version control. Why do we need it? And I like this cartoon, which shows a grad student working with a supervisor. And yeah, this final document gets revisions and then comments and revisions, and it goes on and on and on and on. And this happens all the time. Anybody who's ever worked with another person on a document knows this is exactly what happens. But this is really simple. This is just one document, and it's only two people going back and forth. When you're creating computer software, you've got many different files, and you're going back and forth with not just two people, but there can be dozens of people. And so this is the situation. This is bad enough with a thesis. It was much, much worse when you're trying to do computer software. So when you create R files or any other kind of files, and this could be code, it could be notebooks, it could be documents, there's always going to be changes. By the way, I'm talking about using this with an R package or R functions or code, but this also works very well with our Markdown documents. So this presentation that you're seeing was actually created in R with Markdown. You could also write papers or other documents in Markdown, and they work just as well with Git and GitHub for maintaining the version control. In fact, you're going to see that's how it was done with this presentation. So when you're making changes to your files, sometimes these changes damage the files. You wreck things accidentally. That's what happens. You need to go back to an older version of the document or the file. When you're creating, you need to add and test new features without damaging the current version. So you'll have a version of your program or code which is fairly stable, and then you want to add a feature. But this new feature might wreck what you've already added, and that's very dangerous. So you need to be able to safely add and change new features without damaging the already existing code, which is working okay. Now, this is bad enough when you're doing it for yourself, but it's especially true when you're working with other people, because they need to be able to contribute without damaging your code and vice versa. So the idea of a version control program is it allows you to manage the versions of the files that you create. It allows you to keep them safe and allows you to work on them with other people. That's what they're all about. Git is the most popular version control program in the world, and it was written by Linus Torvalds, who created Linux. So although Git is the most popular version control program, it's actually only the second most important program that he ever created, which is pretty amazing. Because it's by Linus Torvalds, it's free open source software, so anybody can get it and install it on your computer. And the thing about Git, the reason it was created was Linus Torvalds did not like the existing version control programs that were out there. What Git provides is it is distributed version control. We're going to see that it means that it doesn't require a centralized server like SVN or other programs do. It runs just on your computer. And that means that you can be independent of each other and still work together. So that's the advantage of Git. GitHub, which we'll talk about a lot, is a website which runs Git. And the idea of GitHub is it allows you to back up your Git repository. So it allows you to make a copy of the work that you've done on your computer and back it up onto this website. The important thing about GitHub, and the reason why it's so widely used, it's the most widely used online repository, is it really allows collaboration with others. And so this is how you work with other people, with Git on your local computer and GitHub to allow you to work with others. And there are other similar sites out there. GitLab is one as well, and I'm sure there are others, but they all work in very much the same way. GitHub is the most popular one, and it's the one that we are using with our project, so that's the one I'm talking about. But you can also do the same sorts of things with GitLab. So to get Git, it's built into Linux, not surprisingly, since it was created by, both were created by Linus Torvalds. But if you are working on Mac OS or Windows, you can download Git online from this website. And it's git-scm.com, and if you click on that, it'll take you in there, and you can download the software. So how does Git work? Well, when you work with Git, it creates a folder called .git in the directory which holds your project, and that's called the working directory. So you have a directory which contains all the files that you're working on, and there's this hidden folder called .git, and this is called the repository. And what it does is it contains all the versions, current versions and old versions of all your files. They're all stored in there. And when you make changes to your working files in your working directory, then you add them to this repository. You can then retrieve old versions or different versions of the files in the working directory. So it's a partnership you have between your working directory, which contains the files that you're working on right now, and the Git repository, which holds the history really of your project, all the older versions of it. And you use Git to manage these the repository. So to work with Git, if you look online about Git, you will see that it is a command-based program. In other words, you have to type in commands at a command line. Now, this is how many people use Git, but you don't have to. There are also GUIs for Git. And one of them is RStudio, and it makes working with Git much easier. So when you are working with Git in RStudio, you'll see that there's a tab at the top right corner of your screen that says Git, and if you click on it, you will see these different buttons, and that's how you do most of your work with Git. Now, the bad news is that you will still have to type in some commands occasionally. You can do most of Git through these buttons in RStudio, but once in a while you're going to have to type in the command, particularly if things go sideways for you. So we're going to talk a bit about the commands, and we're also going to show you examples of, or show you how to work with the buttons, which are a little simpler. When you create a new project in RStudio, you can add a Git repository automatically. So it's one of the choices. You can also add a repository to an existing project by going in and adjusting its settings. This is a very good thing to do. So when you create a new project in RStudio, add a Git repository. When you clone a repository from GitHub through RStudio, which we're going to see, it automatically creates a local repository. So it creates the folder. You'll see that in this little dialog box. This is from the cloning dialog in RStudio. You put in the repository URL. So this is the location of the repository in GitHub. And you tell it where you want it to go. And you click on Create Project, and it will then create the project on your local hard drive, and it will automatically contain the local Git repository. So that's pretty much how you do it. It's pretty simple. To type in commands, there's a couple ways you can do it. Under Git, you'll see there's that blue gear, and if you click on it, the little menu pops up and it says shell, and that will pop up a shell where you can, shell is just a word for a terminal or a way of entering commands on your system. You can also type in commands in any terminal that you have on your system. And there's also a terminal tab at the bottom of your screen in RStudio. So if you look at the new versions of RStudio, you'll see a console tab and a terminal tab. Click on terminal, and you can see that you can type in commands. So here I'm typing git add-a. That's a git command. So there's several different ways in which you can type in commands in Git. Before you use Git on your computer, like I said, you have to install it, and you also have to tell it who you are. So you have to type in these commands. Every Git command begins with the word Git. So you type in Git to run the program. Then there's a command, which in this case is config, and then the config command is followed by some options. So here we type git config -- global, meaning that this is available for every version of Git, or every Git repository, I should say, on your computer. And then your username in quotation marks, which is whatever you happen to be. And then you type it again, git config -- global, and then your email. And you have to do this. You have to do this once on your computer to tell it who you are. Once you've done that, you can then work with Git, and you'll be able to make it work with GitHub as well. You can also list your current settings for Git at the command line by typing the git config -- list, and it will list out all the current Git settings. So you only have to do this once. As soon as Git is installed on your computer, type this in, and you're good to go. Git is now installed. So, version control. When you're creating code on your computer, you're going to want to add it to the repository. So you're going to want to add it, and so it will be saved. So you can come back to it later in case there's a disaster, or you can go work on different versions of the program. And you should do this frequently. Really, anytime you make significant changes to any of the files in your working directory. What's significant? Well, that's up to you. But if it's something you wouldn't want to lose, I would regard that as significant. So I would make a commit certainly every hour or two. You don't want to lose the work that you've done. Adding files to your Git repository is done in 2 steps. The first step is you stage the files. This means you select the files that are to be added. And the second step is committing them, which means actually adding them to the repository. So it's not a big deal, but you'll see those words used online if you look for help with Git. It will always refer to staging and committing the files. So how do you do this? Well, if you look on the Git tab in the upper right-hand corner, you'll see all the files which can be staged. And in this example, we have 2 files which have been modified. They have a blue M, and there's also one new file which has a yellow question mark. So these 3 files can be staged, and to stage them, it's as simple as clicking on the checkbox beside them. That's all you have to do to stage the files. You just select those. And then once you've done that, you then click on the commit icon. So as you see here, there's a little button there that says commit. So you select these files and then click on the commit icon. Now, before the files are actually added to the repository, a commit window will pop up, and it gives you a chance to review the files before making the actual commitment. So I'm going to show you this, what this looks like. And so this is what the commit window looks like in RStudio. So there's three windows here. On the left-hand side, we have the files which are staged. You see all three of them are staged. You see that the third one now has a sort of turquoise icon with an A on it, which says it's been added. The other two have been modified. On the right-hand side, we have a space for a commit message and the button commit. And at the bottom of the screen, we see lines which are in pink and green. I'm going to explain all these different windows. So the bottom pane is what's called diff, and it shows the changes in all of the files that are there. So right now we're looking at the top file, github.rpres, and it shows the changes in every line in this file. We can scroll over this and see all the changes. This is what diffing is with a file. This is really, really powerful. So it allows you to see every change in every file and to make sure that you want to actually stage this file. Notice we can unstage it. So we could, if we decide, oh, I don't want to actually stage this change, I could just click on the stage checkbox and unstage it, which is very, very powerful. So this is a very useful tool before you actually do the commit. On the right-hand side, we have a commit window. Now, this is there's a space for a commit message. You have to type this in. You have to put in a message about what you've done before you actually commit the files to the repository. This is really important. Why? Because you're going to forget. You're not going to remember why these files have been changed. What was the reason for making this change? Is it a bug fix? Is it just a typo? Have you changed the way things are being laid out? Is it an enhancement? It's important that you type this in. And so you have to type this in before you make a commit. Once you've typed in the message, you click on the commit button, and the files are now added to the repository. That's it. That's all you have to do. If you look in the top of the commit window, you'll see that the button on the top left corner has two pieces. We're showing, in this version, we're showing changes, but there's also a history button. And if you click on the history button, you see the history of all the changes that are made to this repository and who made them. So here we see all the changes that I've made in these slides that are for this actual presentation. And you see the little messages that I've put in. They're not really great. And when the changes were made. So this is very, very useful. The SHA number on the right-hand side, this is a secure hash, and it uniquely identifies this commit to the repository. And there are times when you have to refer to that number, particularly if you are going back to old versions of the files. So that's used to identify each individual commit of files to the repository. Okay, so that's how you add files to your local repository. It's not very difficult, and I encourage you to do it a lot. Git uses branches to organize your code and documents, and these are very important. A branch is arranged just like it sounds, like a branch of a tree. Each repository always has one branch, which is called master, and it is intended to contain the most up-to-date, best version of the code. So if you were going to give the code to somebody who doesn't use GitHub to look at, that would be the version. If you were going to submit it to somewhere, that's the version that you would give to someone. Now, you can create other branches at any time, and it's very, very easy to do that. I encourage you to create them. Each branch is separate. So each branch contains its own separate versions of files, and you can change the files in that branch and delete them without affecting other branches. So that's really important. So if you've got a branch of code which is experimental, you can go in it and make changes to your heart's content, screw it up, and it won't damage any other part of your code. You can add branches at any time. The current branch is shown in the Git tab in the top right-hand corner of RStudio. And when you change the branch that you're working on, the files in the working directory are updated. So if you move from one branch to another, it will change the files that are in your working directory so that they are taken from that branch. So this is very, very simple. You just swap branches and you've got a different version of the files. So this is how we work with our code with different versions. So you can create a new branch at any time. In RStudio, there's a branch icon in the upper right-hand corner. You click on that and it pops up this dialog box. And it says, you give it a name. In this case, I've called it test branch. And it says remote origin. What does that mean? Well, this is referring to where the code is stored online. So this code is also being synchronized with a remote location, which we're going to see is GitHub. This is really important. It's a very good idea to make sure your branches are synchronized with the remote repository, which in our case is GitHub. And as soon as you create a branch, the current versions of all the files, so whatever is in your working directory, is now added to this new branch. And so we're now working in this branch. So to change between branches is really simple. You can switch between them at any time in RStudio by clicking the branch name in the upper right-hand corner. So right now we're working on the master branch. That's why it says master, and there's that little down arrow beside it. Click on that, and we can choose another different branch. We've got one called test branch, which is also on our remote. And we've got another couple of local branches, which are not on remote. So we can swap between them at any time by just selecting their name, and the files that we're working with on our local computer will be updated. So it's very, very simple. I encourage you to make branches, create them, screw them up, delete them. It's very simple.
Kevin, quick question here, just to jump in.
Yep.
Relevant to the RStudio layout. Question from Kerman, which is that there's Git installed, but the Git tab does not show up in RStudio. I believe you need to have some sort of a Git project open.
That's right.
In order to have that tab open. Is that right?
Exactly right. Yes. So, that's only going to be, you're only going to see the Git tab if you have told this project that you are using Git. So if you've cloned a repository from GitHub, it will be in there. If you've created a new project and said to use Git, it will be there. And if it's not there, you can go into Tools and Project Options and tell it that you want this project to use Git, and then you will be able to see it. But yeah, unless you tell RStudio that this project is using Git, it won't be there.
Yeah, I think that answers. Yeah, I think that answers that. And also another question that just popped in, which is the Git panel at the top right corner only appears in R 4.0. I believe the answer is no. The similar answer, it will appear when the Git project is recognized and open.
It does. It's in anything after 2 point something or other. So the computer that I did this on was running R 3 point something or other, and it certainly showed up there.
Great. And we're okay. Sorry, one last one before we move on. Are there any storage restrictions in GitHub, such as file size and max storage restrictions?
Nope. As far as I know, no, none. The only restriction is that if you want a repository to be private, if you want a certain number of private repositories, I believe you have to pay something. If your repository is public, then you do not have to pay for your own personal use. And I think even as a personal use, I think you get a few private repositories.
Mm-hmm. Yeah, I believe there is a size restriction for our packages, but that's separate somewhat from
For CRAN, yeah.
exceptions.
CRAN has a restriction that the total size of the package can't be more than 1 megabyte, but that doesn't. That's just the current version of it. That's not doesn't affect all the old versions in your repository. Okay.
Yeah, we can carry on.
Okay. So the reason for using Git, or one of the big reasons for using Git and GitHub, is to recover from mistakes, and we all make them. And there's lots of ways of screwing up your code. Deleting files accidentally. Yeah, it happens. You could also delete many lines in the file and then save it. Yep, we've all done that. Overwriting files. So yeah, you overwrite a good file with a bad one. That can happen. So all of these are things that happen all the time, and this is why it's a good idea to make a branch before making big changes to your project. So even if the change is purely a positive change, even if the change is only going to be an enhancement to your project, you don't think it's going to damage it, I would still encourage you to make a branch, because you might accidentally screw things up. I've done it myself many, many times. It could be something as simple as renaming an important variable, and then finding out that you've got conflicts. So I would definitely encourage you to make a branch before making any big changes to your project. This website, sethrobertson.github.io/gitfixem, shows how to recover from many, many different types of mistakes. And he's got lots of worked examples on how you can use Git and GitHub to fix screw-ups. So this can include committing bad files, overwriting branches, all kinds of things. I can't get into all the ways it's possible to screw up, but I would encourage you to look through this and look through it before you screw up. I had to look through it after I made a mistake. So I would encourage you to read over this website. He's got a very nice system that takes you through based on how you've screwed up your project. Now, GitHub is, as I said, an external website, and it's referred to as the remote. So you have a repository which is linked to your local repository, and it's the online one is the GitHub is remote. You work with GitHub by making sure that your local repository is synchronized with the GitHub remote repository. It's really important that the two are synchronized with each other. And the biggest problem people get into is when they're not synchronized. So one of the ways you synchronize is what's called pulling. And pulling downloads the GitHub repository to your local repository. And you can do this by using the blue pull icon in RStudio. And it's a good idea to click on pull before you do any new work, and you'll get a message on the screen saying that you are already up to date. Because one of the things that happens is that sometimes you might make a change in your GitHub repository. It's not a good idea to do that because they'll be out of sync with each other. I would encourage you to make all the changes locally, but the pull command will pull them down if there weren't any changes made on GitHub. Now, the reverse of pulling is pushing, and this is the more important button. And this uploads your local repository to GitHub. Now, you should only push to your own GitHub repository. So you should have you should have your own personal repository on GitHub, and that's where you push changes to. And when you push, you'll get this message, and it will say it's pushed to this repository, and you'll see I pushed it to the Center for Hydrology Git for GitHub repo, and there it is. So that's the repository that this is pushed to. So now my local repository and the GitHub repository will both have exactly the same files. So the most important thing about GitHub is the way it enables people to work together on projects. And typically each project has an owner. This is the person who has set the project up. And then there will be one or more people who can also approve changes to this repository. Now, if you aren't one of these people, and really even if you are, you should not be pushing changes to the master branch directly. We're going to see there's a better way to do that, and Rob is going to be demonstrating that. So leave messing around with the master branch to the administrators of the GitHub repository. One of the most important things you can do to work with other people on GitHub is to let people know about issues, bugs really, that are with the code. And it's very, very easy to submit an issue. So this is the CSHS hydrology package, which we've been talking about. And you'll see that there is an issue which was opened by myself. And this is where we are discussing the code which was created by Dan Moore, which does spatial processing in R. And there's a discussion going on about some of the features and how they can be fixed up. And so this is really important. And this is it's important to give good bug reports. There's a great example here on how to write good bug reports, because nobody minds getting good bug reports. It's not enough to tell somebody, well, it doesn't work. Well, that's not really very useful. You need to explain why something doesn't work, what you did in order to make it not work, and so this is the sort of information that's very, very, very helpful. I would encourage everybody who's thinking about getting involved with a project such as the CSHS hydrology package to go online and look at some issues and try things out, find things that aren't working, and submit some issues. It's one of the most helpful things that a person can do. We really appreciate it. So the best...
Sorry, Kevin.
Rob, sure.
Yeah, might be a good time to jump in with a few questions just on the
Sure.
topic of working with people. There's a question from Jason. Nice to see you on the call, Jason. It says, for a final commit, do you find it difficult to merge multiple branches once they get changed a lot? And he cites that the hydrology package currently has about 9 branches.
Yeah, they can be. And so if you've done your job as the administrator and clean things up, it shouldn't be hard. But merging is what happens when you merge a branch in with the main line. GitHub will tell you where there are conflicts. And so if you've got files which don't work together, it will show you those conflicts, and the administrator will then go in and fix them. We have done some branch merges already. I've merged in some code, and it merged fine. We've got some new code that that we're hoping to merge in. I'm not anticipating any problems. Find out when it actually happens. We'll find out when it actually occurs. Just a second. I have to switch phones here. Just a second here. Okay, everybody hear me?
Yeah, we can hear you fine.
Good.
Or at least I can. Hopefully that means everybody else can too.
Okay.
Related question from Jason, is there a quick way to see differences in files and code between the master branch and various others?
You mean to do a diff between them, between the two branches? Well, one really easy way is in RStudio. If you look at the diff window, you should be able to compare them. You should be able to show them.
Great. And then one more before we move on from Marianne, which is when I add a branch, I don't get an option to sync to remote. Did I miss the step to link to remote at the beginning when I signed up?
Yes, that's right. That's right. It can't sync it to the remote if it doesn't know what the remote is.
Great. And is there an easy way to sort of fix that after you've already created the package?
I think what you would, once it's been created, I don't know. That's a very good question. You have to go back and set the properties of this repository in RStudio, and then tell it that it is connected to the remote. And then can you? I don't know if you can then go back and resync this branch. I don't know. I'd have to try it. I've never done that one.
Yeah. Okay. I see a couple of hands raised, but I think we'll wait for the audio questions until the end of the presentation, if that works for you, Kevin.
Sure.
Okay. Great. Carry on.
Okay. So forking. A fork is a complete copy of a GitHub repository, and this is very useful to do. Remember, all the code on GitHub is free open source software. If it's publicly, if you can see it, you can copy it. It's quite kosher to do that. So it allows you to copy other people's work as a basis for your own work. You should also, when you are copying a repository, you should check the license that the code is being distributed under. So because it will tell you what you are allowed to do with any code that is derived from that code. So it's important to look at that license. There's almost always a license on a GitHub repository. There always should be. It also allows you to make a working copy of the repo files without affecting the original one. So this is a really good way to create features or fix bugs. So what you do is you can fork a project into your own personal repository. So you make, and Rob is going to show how this is done. You can then make changes to this fork that you have created. And when you're done with those changes, you then submit a pull request back to the original GitHub repository that you copied from. So a pull request is submitted through GitHub. And what it does is it tells all the members of the project about your suggested changes. And these changes can then be discussed. If the person managing the repository approves, then those files can then be merged in with the specified branch or even with the main branch on GitHub. So this is a two-step process or several-step process. You make a personal fork of the repository. You then go from that personal repository to your local computer. Set up a local Git repository. You make changes on that, push it up to your GitHub repository, and then issue a pull request to the original source. One of the things you're going to see mention of, and I'm not going to go into great detail, is something called SSH, which is short for Secure Shell. And what this does is it provides secure encrypted communication between two computers. And if you set this up on your computer, you don't have to type in your username and password every time you push files to GitHub. Otherwise, you have to type those in, which is kind of a pain. It's built into Linux and Mac OS. You can add it to Windows. And once you've installed it, you have to configure it by creating a key. I'm not going to go into all that, but it's something you probably will want to set up. You only have to do it once. And once it's done, you don't have to type in your username and password every time, which gets to be kind of a pain. So it's something you probably want to look into. So the typical workflow is you fork a repository of interest to your own GitHub account. In other words, you create a copy of this on your own GitHub account. You then check this out to your local computer on your hard drive. You make your updates, changes, new branches on your local account, preferably in a new branch or new branches, definitely a good idea. You then push these changes up to your forked repository on GitHub. And once you're happy with all those, you make a pull request to bring these changes from your repository back to the original. And yes, celebrate having made a contribution to another project. So these are the steps that you should be following. And if you do these, it will prevent you. It will keep your files nicely synchronized between your local computer and your GitHub repository, and it will make it very easy for the project owners, managers to merge your changes in with the main repository. So I'm going to hand over to Rob, who is going to work through a typical workflow with a couple of examples. He's going to use two different repositories. One is of the presentation, and another is our CSHS hydrology package. And I am going to change the presenter to Rob.
Okay, Kevin, you can see my Chrome here. So I guess
Thanks, Rob.
Just Kevin's webcam isn't working, but I don't want to be the only person that's on video here. So that's Kevin Shook for you.
Thanks.
Okay, I guess just sorry. Before we move on, there's at least one question I see here. So this is a good time if you do have any questions from the presentation or anything else. This would be a good time to raise your hand in the utility here for WebEx. So Heather, I see you have a question. I'm going to try to unmute you here, and if you want to ask your question, you can go ahead.
No, sorry, I didn't mean to raise my hand. Thanks, though.
Okay. Okay, no problem. All right, maybe we'll take 1 minute here just in case there are any questions, if anybody does want to jump in. Okay. All right, I'm not seeing anything pop up, but at any time through the next bit of the presentation or the demonstration, if you do have anything, just feel free to either type in the chat window, in the questions window, or raise your hand and we'll get around to questions. So one note of interest is that there was a pre-webinar survey that you sent around, so thanks to everyone who filled that out. And it looks like there's quite a mix of responses and sort of mix of the audience here. So anyway, that's good to see. Good representation, a lot from academia, but also from other public and private sectors, and a good mix of experience with using both R and GitHub. So some that are quite experienced and some that are relatively new to R or have never used it before, and quite a few similarly with GitHub, maybe slightly more skewed towards not having used GitHub, but there's quite a few that could probably teach me a lot about using GitHub as well. So moving into the demonstration portion, we'll first go through and just use the interface and just sort of keep it at that level. And if there are lots of questions, we can obviously jump around and pause and re-explain things. And I will go through and mention, at least give you an idea of what the command line version of doing the same process would look like. And I will mention now, just in case I forget, there will be a post-webinar survey that we'll be sending around. So if you'd be so kind as to give us some feedback, what went well or didn't go well after the webinar, that would be great too. Okay, I don't see anything. So, so a question from Jason, my fork project isn't showing up. Can you show a demonstration of setting a project up in R? Yeah, Jason, we will go through that definitely. And if after the demonstration or during it, if there's still questions or something that wasn't answered, then feel free to jump back again. So I'll just jump to GitHub here. So under, this is, anyway, sorry, hopefully everybody has this. Maybe I'll pop it into the chat for a second. Hopefully you've seen some of the messages going before the webinar to do some installation and take a look at some of these files. So if you haven't done so already and you'd like to follow along, I would recommend that you go and install, download this file and install some of the R packages. These are just, this is basically a script that will install the R packages that are required for the webinar. Again, if you would like to just pay attention and not follow along quite as closely and do it live, then that's fine. But if you want to be running the same things at the same time as me, you'll need to have some of these files installed, or sorry, these packages installed. I think I'll start with just a quick tour. Hopefully everybody has a GitHub account. That's kind of the first step. So if you create a GitHub account, you'll have something like this. Hopefully I have a nice picture of a pre-COVID haircut. And you'll see all your repositories listed here. And if you click on any of these, so for example, here's a Raven R package. This is set up as an R package, and so you'll see an architecture that has R files, has a number of the metadata files, the descriptions, the README, some of the things that our project, which is sorry, can you close your camera window and enlarge the screen? Yep, I can definitely do that. Is that better, Kevin?
Yeah, that's better.
Yeah. Anyway, so you can see all the commits, all the branches. So, for example, if we go to commits, you can see all the different commits that were made and all the comments. So it's a good way to keep track of everything. You can see the issues. So there's a number of issues that are submitted for this package. And you can see all the files here in the organization. And if there was a problem and you need to go back to a previous version, you could do that all online. But I think the main point here is just that all these files are online, so you don't need to have GitHub set up or sort of know what you're doing. You can just go to github.com, find a repository, start clicking on files. You could download all of this and do it locally. So there's sort of ways to get your feet wet before you have even Git installed. So I'll switch over here. This is the Center for Hydrology, Git for R. There are quite a few, I think, Kevin, you can speak to this, but there are quite a few useful things on the Center for Hydrology page. I think there's some other basic R training materials and various other things. So I would encourage you to take a look at the other repositories there. But of course, for this, we'll look at the Git for R section. So there's a number of, basically all the exercises that we'll be going through are in this exercises folder. The presentation, I know there were some comments about putting together slides and things like that for different purposes. So this RMD file is actually the slides. The figures are organized here, and the PDF output is also produced here, so you can take a look at that after. Taking a little while, but if we go back to the exercises folder, that's what we'll be looking at. So if you haven't done so already, you can go into the exercises folder and download that PDF and follow along with what we're doing here. It's taking quite a while here. Okay. Okay, so first thing that we'll be doing is working with this Git for R repository here. So again, I'm now logged in. I have my account set up here, and you see these options at the top. This is basically just to star and watch updates for a repository. So if there's something that you're working on or you're interested in, you can basically subscribe yourself to various updates that might be happening here. Different releases and things like that. So first thing I'm going to do to fork this repository is I'm simply going to click on fork. And again, what this will do, I'll pick an account. This basically creates a clone, or sorry, you got to be careful with the terms here. This basically creates a copy of the entire repository to my local account. So what Kevin alluded to earlier is that you never want to be pushing to a repository that isn't your own. So the right way to work with a project, for example, with this Git for R, would be to fork it to my own account. You see that this is now under my username, same repository name. It says fork from Center for Hydrology Git for R. And so this is basically a complete copy of this repository under my own account, which means that I can work with it, make changes, break it, make new branches, all that kind of good stuff. And I'm not going to create any damage to the original repository, which is what we want right now. So hopefully everybody has now forked that repository. So anyway, you see I have a complete copy here. I think it's still just finishing a few things up. I'm now going to switch over to RStudio. And again, please feel free to just jump in if anything's moving too fast or anything like that. But I'm going to open to RStudio, bring this over here. Okay, Kevin, you can see the RStudio window here?
Yeah, that's fine.
Great. Okay. So anyway, so as was alluded to in the questions, we don't have the Git tab here yet because we don't have any projects open. This is just, opening RStudio directly. To create a new project, we're going to go File, New Project. If you're creating just a new project without Git, you could go to New Directory and set it up that way. Today, of course, I'll be focusing on Git. So we're going to go to Version Control. We're going to pick Git. Subversion is just another that Kevin alluded to. Another repository system that does something similar, but we'll be using Git. So for the repository URL, I'm just going to switch back to my browser here. What I'm going to be doing is I'm going to be grabbing the URL for my version of this project, for the fork version of Git for R. So I'm just going to copy that. I'm going to switch back to RStudio, and I'm just going to paste that in directly. and you see that it automatically names the project directory with basically the last after this the last slash here, so it automatically pulls the name there. I'm just going to change the folder here to something temporary. So normally we'll put it under Documents, GitHub, something like that. I'm just going to switch to this temporary folder here. Okay, and I'm going to hit Create Project. Once forked, sorry, question here from Robin. Once forked, are updates in the original repository synced to your fork?
No.
No. Yes. Yeah, Kevin, do you want to speak to that for a second?
They are not, but it is possible to set that up. So the default is not to have them synced, but it is possible to do it. I've never done it, but apparently it can be done.
Yeah, okay. So I've just hit Create Project, so it's now going through and making this project.
Well, just a quick response while that's happening. Well, we had a question about how can you see the differences between file and code between the master branch and other branches? There's I pasted in a command. I don't know if everybody can see it, but yeah, there's quite a simple command to do that. You say you just say git diff the branch 1 ... branch 2. So it would be master ... whatever you want, and that would diff the two branches.
Great. Okay, so I've now created this repository, and basically step 3 was just forking it to my account, which is what I did in browser. And what I just did was step 4. So I've now made a local copy of the presentation repository by cloning the repository. So it's now local. If I were to open up file folder, and again, I'm doing this in Windows Explorer and on a Windows system, but this is quite similar in a Linux system. So R in general is pretty good, RStudio included, about being relatively platform independent. Not 100%, there's a few nuances here and there, but generally speaking, it works quite similarly across platforms, which is nice. But yeah, if you go to the folder now, you can see I now have Git for R and all the files are here. So I could open up this PDF and anyway, all the files are there. Okay, so we're now going to delete the file that says this is junk from the local repository. So if you go to the Files tab here, we want to go to, what do we say, the Exercises folder. So we click here, we see a number of files, that PDF, HTML of the same thing, and the RMD file, and we have this file called This File Is Junk. If we click on it, it will open. It says this is a junk file, please delete it. Great, so we can close this. We're going to click on this in the files window here and click delete. And again, this is just going to do the same thing as if you went to Windows Explorer or whatever Explorer and deleted it there. You'll notice, by the way, that after I open this project, this Git tab is now available. If I go to under here, sorry, I should have gone to it before, but it would have been blank because there weren't any differences. Now you see that there's a D for deleted, and it shows that basically a change has been made to this repository. Okay, before we do anything else, I'm going to go back, and it's asking us to change, make a change in the README file. So this readme.md in the main Git for R folder, I'm going to click on that, and you see here's some text. If you've attended the R Markdown or webinar or used R Markdown before, you'll kind of notice some of the syntax with the double star for bolding and things like that. If I switch back to my browser here for a second and I scroll down, this readme.md, this is basically what shows up automatically on a GitHub repository page. So you'll see Git for R, some information. Usually there's some information about the package, what it does, how to install it, how to contribute to it, stuff like that. And this is basically coming exactly from this readme.md file. Okay, so it's asking us to make a change. So I'm going to say something like, this webinar has currently 94 attendees, smiley face. I'm going to hit save. Okay, you'll notice that as soon as I hit save, that file has been modified, and you see the M appear for readme.md. Okay, we're now going to go ahead and commit the changes, and we're going to stage them first. So step 1, we're going to stage them. You can click them individually or select both and check the box. and they're now both staged. Okay, simple as that. If we wanted to, we could click on diff. Good use of this tool here, and this will basically, if you click on an individual file, it will show in green highlighting what's been added, and if you click on the other file, it'll show what's been removed, which in this case, it was only one line, but everything's been removed, so the whole file shows up, all the text that was inside that file shows up in red. Okay, no problem. This would actually be a very similar window to if you just hit on, hey, click commit, so I'll close this for a second, click commit. I'm now, let's say I'm happy with these changes, I want to push it, or at least make a commit back to the online repository. So I'm going to enter some sort of obligatory message. Usually this should be something with which files were modified, something like that. Make it sort of short and sweet but specific as possible. Let's say deleted junk file in exercises folder, something like that. Okay, so I'm going to hit commit. Okay, so I've now basically, here's the tracking number. So if you were to go into the repository, you could see, and I've basically made two files changed, 2 insertions, 1 deletion. So 2 lines added, 1 line deleted, and it shows some information there. Great. So now I can hit close. I can push it directly. I'll use the button here just to kind of show. You'll notice this little information button pops up here, which says your branch is ahead of origin master by 1 commit. This is basically just saying that I've now made 1 commit difference compared to what's in origin master. Okay, so now I'm going to take the big step to push this back to the online repository. So I'm going to hit push. If you haven't done it already, you may need to enter credentials. I already have mine saved, so it didn't prompt me for them, but depending on how you have it configured, it might ask you for a username and password at this point. But otherwise, you can see these changes have been made to the master. Okay, so I'm going to close this. I'm going to go back online. So I'm now back here with my username Git4R and refresh this page. Okay, and it's now shows I'm now 1 commit ahead of the original Center for Hydrology master repository. You see here's the note that I made these are the files that were, sorry, that's not the one. I made a change to the exercises folder, and I made a change to the README. So you see the commit messages pop up there. And if I scroll down, you now see my messages appearing in this README section here. Okay. So now that's basically the workflow for, making a change in your own local version of the repository. Now, if I wanted to make a contribution back to this original one, which is really what we're trying to do here ultimately, I could click on pull request. I won't go through and actually do this, but at least show you what it looks like. So it'll say making a pull request from my RHLM's Git4R back into the master branch of Center for Hydrology Git4R. It says able to merge because there's no conflicts. If, for example, someone else such as Kevin had made more changes to Center for Hydrology since I had made changes here, there would be potentially some conflicts, but in this case there aren't any. And if I wanted to, I could click on create pull request, and then it would leave it up to Kevin or whoever the manager is for that repository to review the pull request, potentially ask for other changes. Maybe he wants to update the number here to say actually now it's 90 or something like that, and he could decide to merge the pull requests and make that update into the main repository, request other changes, things like that. Okay, so I won't do that right now, but that's how you would submit the pull request to go back. And that's basically it for steps 3 through 9 for the Git4R presentation. Are there any questions about anything there? Okay, so question here, what should you do if you want to commit without changing anything? For example, you want to acknowledge that you checked a file that they work, but haven't actually changed any code. So I think maybe Kevin, you can speak to this as well, but this sounds like you're getting more at code review and that kind of stuff.
Yes, so that's right. That's where you could, it's really more you're telling the person some information rather than changing the file. So you could submit, you could send them an email, but you can also submit an issue as well.
Yeah, so yeah, if you want to basically show that you've reviewed a file, I'm not sure what the best way to do that is, but if there was an issue with something, there would be potentially an issue tab here. So someone would say, I'm having an issue with this file, and if you wanted to review, you could basically go through there and provide comments to say, here's what I would suggest as changes, and I've looked at this, and you can go ahead and now do something with it. If there's a pull request, like I just mentioned, for example, Kevin found an issue with something I did, then he could basically comment back in that pull request and request changes, or say I've now looked at it and leave it to someone else to actually make the pull request. So there's different tools for managing that. I think that's a little bit different from making commits though. Okay, that makes sense, great.
Yeah.
Okay, I think we're ready to move on to the next part. So that was working with this Git for R repository. I'm now going to switch tabs here to the hydrology package. So this is the main package that we've been talking about, the Canadian hydrology effort. So kind of as you saw in the webinar, the organization basically has a note like the project file, which just tells in R that it's a project, has a description, a few other files, what the license is for the package, some news, this README file, which shows up here. So again, it shows how to install the package, what is CSHS hydrology, etc. And then the all the R functions would be contained in this R folder. So you see all these .r files. Anyway, so we don't have to get too much into that, but this is basically an R package architecture. Yeah. So now we're going to do the same thing. I'm going to click on fork. So this is basically going to create a copy of this whole package to my account. I'm going to fork it to my account. It says it should only take a few seconds. We'll see if that's true.
There's
okay, not too bad. So I now have basically my version of this repository. It tells me where it was originally forked from, and I can now go nuts and break this package as I want to in the effort to update it. So again, I'm going to copy this, close, go back to RStudio here. Okay, so I can basically close this. I'm going to close project. I could open into another one, it would still do it, but anyway, just to show that, close the project. And I'm now going to go through the same steps. I guess I should know this earlier, but I think I can make this slightly bigger here too. So I'm going to go File, New Project, go to Version Control, go to Git, paste that repository in. Again, this is my version of the repository, and automatically creates a name and put it in this temp webinar folder, create project. And it will basically download all the files from the master branch, open the project. Okay, so that was step 2, or sorry, not step 2, step 11, creating a local version of this package on my computer. And again, if I were to open Windows Explorer, go to my temp webinar folder, I now have all the files there. Okay, now we're going to do something exciting, which is build the package. One thing to note here, Kevin, as an offhand comment, I wonder if at some point we should have a whole webinar on just building our packages. I think that would be helpful. But
good. Yes.
Yeah. Okay. So just in these comments here, if you don't understand what's going on here, don't worry about it too much, but I'm basically going to check install and restart so that when I click the install and restart button, it will rebuild the package for me. And just to save some time in the live demo here, I'm going to uncheck vignettes just so that those don't get regenerated. Okay, so I'm going to click OK, and then I'm going to click install and restart and cross my fingers and hope everything works. So far, this is just working on off the master branch. So as Kevin mentioned, usually the master branch should be sort of the best version of whatever the software or the project is. So if this one doesn't build out of the box, then there's potentially some issues, and something got pushed to the main master branch, and it shouldn't have something like that. But in this case, you see it went through, built the package, no problem, and now reloaded the library. So that's great. So now it's in my space here. So if I would type in CSHS hydrology, I can now see all the functions that are in that package, which means that basically that it built and loaded properly. So that's great. For more in-depth checking, I won't do it right now. But basically what this did is it went through and built the package, which means that it compiles fine. If you click on check, it will basically do a much more comprehensive check of the package. So this will look for any link in the metadata that doesn't exist or doesn't work. It will do a whole slew of checks which are necessary to get the package onto CRAN. and it's much more comprehensive than just building the package. So I think that's all I'll say about that there, but if you're interested, you can click on that and see what the output is. So we're now going to create a branch called testing. So we'll go through and actually create a new branch. So we'll click on the Git tab here. Just when I built the package, you can see that there were some changes made to some of the files. And you'll see that if I click on this button here to create a new branch, let's say testing, see remote origin, and I'm going to leave sync branch with remote checked. I'm going to click on create. Okay, so that created it, or what is creating it. Great, so I can now close this, and I have a new branch called testing. If I want to switch back to the master, it's as simple as just clicking there. Let's go back to testing. No problem. You'll notice if you switch between branches and there's different files in the branches, the files down here or in the Explorer will actually change when you switch between branches. Okay, not seeing any questions, so must be going at the perfect pace here. Okay, so we're now going to go to the R folder. So we're in our testing branch, we'll go to the R folder, and we basically want to create a new file. So just to keep things simple here, I'm just going to make a copy of this one, and I'm going to name it, this is junk. Did I spell that right? Junk with an N. There we go. Okay, so I've created a new file. You see that this file pops up here immediately under r/thisisjunk.r, and it's not staged, and you can tell because it's not tracked, and it's not staged also because of the double question mark. So basically, if you add a new file to this folder, either here or directly in Windows Explorer, Git will not automatically track it. You have to actually add it to the repository and then go through staging the commits and all that stuff before it is part of the repository. And sorry, I meant to make this a .txt, so I'm just going to hit rename .txt. Great. Okay, so I'm going to open this file up. I'm going to get rid of all this wonderful code here, and I'm just going to type, this is a junk file. Great. Save that. This is already updated to .txt instead of .r. Okay, so I'm now going to do something that I've noted here is in line with poor practices, not good practices. I'm going to go ahead and commit the changes without actually rebuilding or testing. So again, don't do that ever, but just for the sake of this demonstration, I'll go ahead and do that. So I'm going to select all these files, click check to stage them all, so they all get staged in one, well, I guess 2 clicks. So you see that most of these are modified because they already existed, they just were changed or modified. And this junk file was actually added to the repository. Okay, so I'm now going to click on commit. Okay, so these are all still staged here. I'm going to say rebuild the package and added r/this is junk.txt. Okay, and click commit. So that's sent off. Okay, and then before I push, it says check the testing branch, does the package build properly? So we're going to close this for a second, go to the build tab here. My settings should still be the same, so I'm going to click install and restart, and we'll see what happens with this testing branch. So you see it's going through, it's updating everything, and great. So it's still rebuilt. You'll notice that even though this is here, this is rebuilt. So now if we try to change this to an R file, it's going to try to compile it as an R file, and we'll see if it still builds. So in this case, it tried to compile this as an R function instead of leaving it as a TXT. And now we get some errors where it doesn't recognize symbols, of course, because it's not a real R function. So anyway, just to show some of the nuance there of what happens with R files in here and building packages and checking them before you make different changes. So if I wanted to change this to an actual R file and just do something like, at least something that will actually compile as an R file, hit save and rebuild. This is basically just taking a normal distribution sample of 1, and you see, sorry, lost it there already, but it basically just compiled that and computed it in the compilation of the package, and this now should rebuild. Even if this doesn't make sense, at least now it compiles. Okay, and then if I wanted to, if I was happy with that, could go back to Git, restage these files. You see that this is now a new file that's added and the .txt version was deleted. I could stage both of these, go to commit, and let's say I wanted to amend the previous commit instead of making a new one, and just make this .r, update the previous commit. Great, and then I could push changes and it would push to the remote repository, or sorry, the origin. Okay, so the last thing we're going to do here is we're going to switch to, just to show what's happening with some of the other branches in here. So I'm going to click on Danmore Spatial. So we're basically switching to another branch. Yeah, we're going to close that file because it was just removed from the filing system when the branch was switched. Okay, and now if we're in the R files here, you see that there's a whole lot of other spatial hydrology functions that are just in this branch currently, have not been merged into the master or the other branches yet. So for example, this is a contours function, create contour lines from a DEM. A lot of these are wrappers for the RSaga package. And anyway, there's some helpful things here with the spatial branch. So there were some notes in the, oh, I can't see Danmore Spatial. It's here. Sorry, at least on my screen it's here. I'm not sure if that's meant to be, I can't see it on your end or where.
Yeah, is that you're not seeing it on the screen or you're not seeing it on your computer is the question, Sarah. It doesn't show up as a drop-down option. You can see other branches, but not that one. Okay. I don't.
I wonder if it's, maybe it needs to be resynced. I'm not totally sure.
I don't know either.
Yeah. Yeah, it might be that there is a, Sarah, that you have an old version of the hydrology package and it needs to get repulled to get the latest changes. I think the Danmore branch was potentially a somewhat newer branch. So if you checked out the hydrology package a number of months ago, it may not have been in there at that time. So anyway, but if you pull it from or fork it from the main one now, then it hopefully should be there. Okay, a few other questions here popping up.
Yeah.
Are there any significant errors that check doesn't catch or doesn't catch most errors? My thoughts on that is that it's pretty comprehensive in terms of compiling the package. Obviously, what it doesn't catch are if your function doesn't work as intended. As long as it compiles, it will not, it will pass the check. But if there's an error, for example, you have a function that says what is 1 + 1 and it spits out 3, it's not going to flag stuff like that. So yeah, I guess there's a difference between checking for compilation and checking for accuracy or intended outcome or things like that. Kevin, I don't know if you want to comment on the check question there.
It's very, very anal. It will flag almost anything with a warning, even spacing and things like that. So it actually does a very, very good job of finding potential problems in your code. Of course, as Rob said, if you it's not going to, it can't check to see if the mathematics are correct. But in terms of code errors, yeah, it's very good at finding that. There's a question here about how do you handle raw data input files used in developing or testing the code? Do you ignore them or preserve them as a reference for how input needs to be? I guess it depends on the files. So we've got, in our package, we've got some built-in files which we actually use in the data directory. So there's some files, and some of it, so there's a data file, the W05AA008. That's a small amount of data which is used for demoing how files, how functions are used. So we put that in so that we can test functions and demonstrate how they're being used. One of the problems with CRAN is it does have that 1 megabyte limit. And so this is something we have talked about, how we're going to include larger amounts of data. And Dan Moore has actually talked about that. It's possible to download other data sets online dynamically, and we might want to do that. In terms of just testing your own data, yeah, you can put it in gitignore, and that's a file in your directory .gitignore, and it contains a list of files. Rob's showing it right now, which will not be made part of the package. Will not be made part of or loaded in to Git, and so that's very useful. Personally, I just stick them in another directory. I'm lazy. I just have a reference file for testing files. I just have it reference files in a different directory, and then it's not really an issue.
Yeah, great. Question here. So you open Dan Moore Spatial from your GitHub version of the repository. Yes. So if I go, sorry, to online here. So this is my version of the hydrology package, and even here, you can see that all these branches are here. So when I forked the original CSHS hydrology repository, I basically took all the branches with it. And now when I go here, when I originally opened that project, it went to the master branch, but I can automatically, since I've basically forked them all, I have access to all of them. And when I click on one of the other branches, so for example, if I now switch to CH prefix, which was loaded in the original repository, I can still switch to it even in my local version and make changes on that specific branch. Yeah, hopefully that kind of clears it up. You basically get all the branches when you fork the repository. And of course, you can create your own and add them. So the testing branch would be an example. That's currently just in my local one, but if I wanted to, I could basically push that back online. It would exist just in my version of this. And if I wanted to say, say to the original package or original repository, you should have this testing branch for XYZ, I could basically make a pull request and basically just send just that branch back to them. Anyway, so yeah, different ways of working with things. Hopefully that kind of answers that question, Robin.
Jason has a question here about best practices for working with Git in terms of file name conventions and folder conventions. Well, with our package, CSHS Hydrology, we do reference the conventions that we're using with the R code, and because it's an R package, the folders are very rigidly specified. So we don't get to use folder names other than the ones that are in here. R is very picky as to the names of all the folders. When you build an R package, it actually creates a skeleton with all the folders in it, and sometimes you have to add some more folders. So for example, what Rob's showing right now, there's a data folder, which is where our data files go. In Xdata, there's other files as well. But all this is defined by R, so we don't get any say in that. In terms of the branch names, we haven't developed any standards on those. Often they are the name of the person who created it, as well as what it's about. So, for example, Dan Moore Spatial is Dan Moore's spatial code. FloodNet is a huge commit of functions from the FloodNet project, and that's undergoing testing right now. There's a few in there that could be deleted as well, but mostly, I guess it's just common sense. How would you resync if you forked something and need to refork it? In terms of reforking it from the upstream directory, I don't know. Do you know about that, Rob? How would you make yours to make it even with the master directory? I don't know how you would do that.
So I'm currently not in a position with these to show, but I had to do this a few times in preparing for this. So essentially, you could do again, it's not going to show up here because it's currently even, but you could actually click on pull request.
Okay.
And you could actually reverse the direction
Oh,
here.
cool.
And so, for example, right now it's trying to put, my non-changes from my
Right.
version of the hydrology package into the CSHS CWA version of it. But if, for example, I made changes to the Git for R repository on my version, and I needed to get Kevin's updates back into my local version of that of the fork Git for R, the archlums/Git for R repository, and so I could actually submit sort of a reverse pull request to pull Kevin's changes back into my version of the repository here. And that would basically accomplish that, where I would get all the updates from the upstream repository. Not that it's best practice, but if all else fails, you can always, delete this repository and refork it. But the easier thing to do is just to actually create this pull request to your own fork version and get the updates.
That's clever. I didn't know that one. That's interesting.
Yeah, I mean, again, so something Kevin said earlier, which I think should resonate, is that none of us are experts at Git here. So I figured out how to do that about a week ago. But yeah, so anyway, there's definitely lots to learn, but yeah.
There's one more question on there, Rob.
Yeah, so have you ever run into issues working with RStudio Git repo combination on a shared server location, i.e. not locally on your computer? I can't speak to that a whole lot. Typically, if I'm developing some sort of R package or doing something with RStudio, I'll do it locally and I won't do it on a server. Sorry, Kevin, I think we're getting some feedback potentially on your end. That's better. Anyway, yeah, so basically any of the RStudio type of work, I usually don't do on a server. Anything that's on a server, I'll usually just use compiled packages and won't do development on there as much. It should work essentially the same. I don't think you'd be able to use RStudio depending on what type of server you're using. I don't know how well GUIs will work on a Linux server system, but in general, there shouldn't be an issue to at least run the git clone commands and that kind of stuff.
Okay, is Git supposed to be saved under user bin Git on Mac OS? RStudio says it is not detected on the system path. I don't know. I've never installed on Mac OS. I don't know where Git would be installed. That's a very good question. You can always add it to the system path, I would imagine.
Okay. Yeah, I can't comment too much on the Mac OS installation. Yeah. There's a question here, or sorry, comment here. I've worked from Sarah. I have worked with Git on a shared server. You have to copy stuff to your local computer and then not touch the one on the shared server.
Okay.
Okay, great. Thanks, Sarah. I suppose one thing I forgot to mention earlier is that if you go, I'll see if I can switch here back to my Git for R. So again, if you attended the R Markdown or have used it before, you might be familiar with this sort of functionality, but in this RMD file for the exercises, which is used to generate this PDF, I have a number of R sections here, which are actually not included in the PDF. So they basically don't run and they don't show up in the PDF, but these are basically commands if you wanted to run things through a command line. So for example, once you fork the repository online, if you want to clone it or make your local version, it would be basically git clone and the URL. So that's pretty straightforward. To make commits, so you can see there's git status, which you could use to get the status. I can, maybe run this live right now actually and say git status, and it basically says up to date with origin master. So you can type all your git commands here in the terminal. You can go shell, and on Windows it will open the DOS command prompt. You could type it there as well. Or if you really prefer R, you can basically use the system command and run system commands directly in this R Markdown or whichever R file you have. So I should mention, yeah. Anyway, I won't go through all these, but this is basically all the syntax is in this exercises RMD file. If you wanted to go through on your own time and basically try to do this just from command line, do all the same steps. Kevin, do you see anything else popping up here? I'm not sure.
No, I think that's about it. So that's pretty much the end of Rob's demonstration, I believe, Rob?
Yeah, I think that's it on my end. So I think we can switch back to finish off the presentation on your end,
Okay.
Kevin.
Okay. And can you make me the presenter?
Yeah. Here we go.
Okay. Okay, so we had intended that this would be the time to ask further questions. Are there any more? Or is this all very clear?
Yeah, I'm not seeing any, Kevin, so I think that could only mean we've done a fantastic job here.
Okay, well, assuming there aren't any more. So wrap up, there are lots of resources online. This is one of the great things. Git and GitHub have got, and it's one of the reasons for you why I've stayed with GitHub, is because there is such good support online for it. Lots of information for GitHub and working with R. As it says, there's many cool things that can be done with R and R Studio and Git. So as was mentioned before, this presentation was done in our studio with Markdown, and you can do papers, reports, web pages, etc. What's really cool though is because all this works with Git, you can use it, and Git works with any text file. It will diff any text file. So it means that you do version control of documents. So if you aren't writing Word documents, if you're writing your papers in Markdown, you can diff them, and so you can work with another person almost seamlessly by working that way. So this is a nice way to work on complex documents. It's an alternative to what we saw in that cartoon going through the umpteen versions of file names, which are just a pain in the neck. So I encourage you to think about doing that. After the webinar, Rob mentioned that we have a post-webinar survey, and we'd like to get your input on it. That would be very, very helpful. Just click on that URL, and and it should take you in there. There's a question, will there be a copy of the presentation archived somewhere to download? Will it be posted? Yeah, it's already posted. It's actually on GitHub. So if you as well as CSHS will be, I believe, distributing the presentation. But if you go to the GitHub repository, you can download it. I'm going to go right up to the beginning of my slides, and you'll be able to see where it is. A recording of the presentation will also be posted. And that's just a plug again for CSHS hydrology package. It would be great to have you contribute. We have a newsletter which we send out once a month. We have a monthly meeting, and we're always looking for ideas. We're looking for people to review code. This is really what we need help with right now. We've got lots of code in there, but we need people to test it. We need people to download it on your computer and try and break it. See what happens. Does it actually function as advertised? So that would be great, and stay tuned for more webinars in the future, definitely. So with that, I am going to go back to the location of our presentation, which is here. So all the files are available at github.com/center-for-hydrology/git_for_r. If you go there, clone that repository, you'll have this presentation and all the files that were that made it up. So it's all there. Anything else? Rob?
Yeah, just a quick comment here. Note from Robin saying that as an intro user, I feel I have gotten a fantastic intro and I'm ready to dive in and start learning. And that really was, I think, the intent of putting this together. The slightly selfish intent was to get more people available to work on the hydrology package and at least feel like it's accessible. And of course, it'll be hopefully super helpful for any other R packages, projects, papers, presentations, anything like that you work on in the future. And I will say, just on my side of things, doing work in the PhD, it's definitely great to have everything backed up on Git, all the major projects, so that you don't have to worry. I mean, there's different ways to back things up, but having many of your project files and things like that backed up on Git gives you that peace of mind to know that if your laptop dies tomorrow, your files aren't lost, and it just helps to keep things organized. And as Kevin mentioned, it's very easy to mess up files, and then if you don't have that repository tracking version, it can be very difficult to find the previous version and restore your work. So there are lots of good reasons to be using Git, and hopefully that, as Robin mentioned, hopefully that provided the nice intro, just enough to get everybody working using Git.
One question from Jason about CSHS specific questions. If it's for CSHS, you can email them directly. You see there's a website, cshs.cwra.org, or if it's with the CSHS hydrology package, you can contact us through GitHub as well. Can I create Git for an existing R project? Absolutely, yes. You can. That's one of the project options. You can go in and you just say, yes, you want to use Git. Okay. Well, if that's it, if there are no more questions, I think we're pretty close to the end. What do you think, Rob?
Yeah, I think that's about it. So thanks everyone for tuning in and hanging in there for this hour and a half so far. Please, if you're not already, get on the CSHS newsletter. There's also a separate CSHS hydrology newsletter. We have meetings once a month to talk about what's going on and get people involved, and any efforts are appreciated. So don't feel that if you don't understand Git or you don't understand R or you don't understand either, that should be a barrier to getting involved. Yeah,
absolutely. Yeah, I agree, Rob. And yeah, that's all from me.
Okay, well, yeah, thanks again, everyone. Stay safe, and we'll be doing more of these webinars. So if you do have ideas or suggestions, or you'd like to help out and actually run one of these webinars, we're more than happy to get any feedback and volunteer efforts from anyone who'd like to do something like that in the future. So please fill out that survey link and stay in touch.
Thanks.
Okay, take care, everyone.
Bye-bye.